Okay, the first question I'm going to explain is question 9.13 from the chapter 12 practice. It is about the uniform ladder resting against a frictionless wall. So I've made the solution and I've drawn out the situation. Okay, and I've labeled all the forces that is present. This is the ladder and which is resting on the ground. The vertical forces that are present is the 500 newtons. That's the first force, which is the weight of the ladder. Second force, which is the weight of the firefighter that is standing 4 meters along the ladder from the bottom. And last vertical force that is present is the force exerted from the ground. The horizontal forces that are present is the normal force exerted from the wall and the static friction on the ground. Okay, so firstly, I've written the forces in the x and y direction, this and this, based on the information. So we can see that actually the static friction the static friction force is equal to the normal force. The third equation that I've written is the torque, and I take the torque about the axis at the foot of the ladder at 0 here. Okay, and this is the torque equation, R times F, R being the distance and F being the force. So I've done it for the forces, and the negative forces are the forces that is going in the clockwise direction, while this force, the force exerted from the wall, is going in a anti-clockwise direction and is therefore positive. So I solved the torque equation to find the force exerted from the wall, and eventually I'll get it to be 268 newtons. Next, to find the force, the horizontal and vertical forces exerted by the ground on the base, I'll use the first equation that I've written here. Since we know that the friction force is equal to the normal force exerted from the wall, we know that the friction force is also 268. The static friction force is also 268 newtons in a positive x direction. And to find the force exerted by the ground on the ladder, we use the second equation that I've written at the start to find the force exerted by the ground, which eventually is 1,300 newtons in a positive y direction. Part B asks us to find the coefficient of the static friction between the ladder and the ground when the firefighter is 9 meters from the bottom. And I have to set up a new torque equation since the firefighter is now standing 9 meters from the bottom instead of the part A, which says that he is standing 4 meters above the bottom. So this is the second torque equation that I've written, and at the same thing, I'll find the normal force, which in this case is 421. Coefficient of static friction force is also equal, which is 421, and I'll use this equation, which is the static friction equation, to find the mu, which eventually turns out to be 0.324, and that's the answer. Now I'm going to talk about the second question that I did from the chapter 12 practice. It's 9.19. So I've drawn out the diagram for this situation. It is about a knight setting out from a castle, but the drawbridge has stopped. The drawbridge makes an angle of 20 degrees from the horizontal, and the knight and the horse stop at a distance 1 meters from the far end of the drawbridge. And both the horse and the rider have a total mass of 1,000 kilograms, which we can multiply it by 9.8 to find their weight. The question also tells us that the drawbridge is a total of 8 meters long and has a mass of 2,000 kilograms, and we can put the force in the middle, which is 4 meters away from each side, to get the weight of the drawbridge, which is 2,000 kilograms times 9.8 meters per second, to find the weight. And the question also says that there is a lift cable which is attached to a point 5 meters from the drawbridge. 5 meters from the drawbridge is here, and that's the cable. It is attached to the castle by a hinge, and the cable enters the castle at a point 12 meters above the drawbridge. So 12 meters above the drawbridge. And the question asks us to determine the tension in the cable and the horizontal and vertical components of force that act on the hinge. So firstly, I will find the cable, like how far the cable stretches out in the x and y direction respectively. From here I can see that it stretches out 4.70 meters and 1.71 meters in the x and y direction respectively by using this. Okay, so I also want to know the angle that the cable makes with the horizontal, and I will use the inverse tangent y over x, which I did here, tangent inverse y, and the y I add the 12 meters to it, which is from the question, to the 1.71 that I got, and I got 71.1 degrees, and that's the angle that the cable makes with the horizontal. So to answer the first part of the question, which is finding the tension, I make a torque equation based from this as the axis, the left side of the bridge as the axis. This is the equation that I got. This is the equation I got. And just by rearranging the equation, I will get T, which is 35.5 kilonewtons. And that's the tension. To answer the second part of the question, which is the horizontal component of the force, I will set up the equation for the x-axis, which is Rx minus tension cosine 71.1. And based on the answer from part A, tension is 35.5 kilonewtons, I will get Rx to be 11.5 kilonewtons to the right. And I do the same thing for the vertical component. We equate it to 0 too. And since there are more forces present vertically, which is Ry, the weight of the rider and the horse, the weight of the bridge, and lastly the tension, this is what I did, and I got Ry to be 4.19 kilonewtons acting downwards. So this is my solution.